We'll continue the second chapter. This is exercise 2b, question number 10. The velocity time graph of a moving body is given below. You need to find the acceleration in AB, BC and CD, displacement in each AB, BC and CD, and the total displacement. So from velocity time graph, if you want to find the acceleration, what you have to do is you have to find the slope. Now the formula of slope is y2 minus y1 upon x2 minus x1, or if you know trigonometry, you can use the formula as tan. We will not use tan here, we will just use y2 minus y1 upon x2 minus x1. AB, now coordinates of A are 0, 0, coordinates of B is 4, 30. So when you subtract y2 minus y1, you get 30 minus 0 upon 4 minus 0. So that will be 30 upon 4. Answer will be 7.5. Remember the unit is meter per second square. Similarly, BC. Now BC, if you see, at B the velocity is 30. At C the velocity is 30. So actually the velocity is same. So there is no acceleration. It is called as zero acceleration. The body is not accelerating at all, since the velocity is constant. C to D, it is going from C towards D. So the slope, the coordinates of C are 8, 30. That of D is on x-axis, so 10, 0. When you find y2 minus y1, it will be 0 minus 30 upon 10 minus 8. So 0 minus 30 is minus 30 upon 10 minus 8 is 2. You get 30 minus 30 upon 2, that is minus 15 meter per second square. And it is clear from the diagram that the speed is reducing. If speed is reducing, means it is retardation. Hence you are getting negative acceleration. Third part is the displacement in each of the part AB, BC and CD. So for displacement, you need to find the area. Just focus on AB. The area below that, it is in the form of a triangle. So the formula is half into base into height. Base is 4 and the height is 30. So half into 4 into 30, you get 60 meters. Whereas below BC, if you check, that triangle, actually it is a rectangle. So area of a rectangle is base into height, or you can say length into breadth. So length is 30, breadth is 4. Between 4 and 8, it is 4. So 4 into 30, you will get 120. For CD, again it is triangle, half into base into height. Fine. So half into base is 2, height is 30. So answer will be 30 meter. So first answer you have got 60. Second you have got 120. Third you have got 30. Next you have total displacement. To find the total displacement, you have to all the answer. So the answer will be 30 plus 60 plus 120. Hence you will get 210 meters. That is the displacement. Okay, so here is the answer. Now the 11th sum. A ball moves on a smooth floor in a straight line. So you have to imagine. In physics, in order to understand the concept or to understand the numerical, you have to imagine whatever is given. A ball moves on a circular floor in a straight line with uniform velocity 10 meter per second for 6 seconds. So imagine a ball is rolling in front of you for 6 seconds with a speed of 10 meter per second. After 6 seconds, the ball hits the wall and comes back along the same line to a starting point with the same velocity. Means the ball is going, it is hitting the wall and it is coming back with the same velocity. So if it takes 6 seconds to go, it will take 6 seconds to come. You need to draw the velocity time graph. So on y-axis you will draw velocity, on x-axis you will write the time. Fine. Now the total time taken is what? 6 plus 6 is 12. So on x-axis you will mark 12. 1, 2, 3, 4 till 12. While going the velocity was 10. While coming back the velocity is 10, but the direction is opposite. Physics, opposite direction we show by negative. So while going the velocity was 10, while coming the velocity is minus 10. Hence on y-axis you will have 10, that is above, and minus 10 below. So the diagram will look something like this. Fine. You need to find the total distance covered and its displacement. See, displacement is very easy. It is 0 because I started from that point and it ended there. So initial and final points both are same. So the displacement will be absolutely 0. But the distance moved will not be 0. Distance will be from this graph. If you want to find the distance, you will find the area. So you can see there are two rectangles. So you find the area of the above rectangle and the area of the below rectangle and then add. So above rectangle area will be length into breadth, that is 6 into 10, 60. Below also 6 into 10, it will be 60. So when you add it, you get 120 meter. Very easy sum. Next sum, question number 12. There is a diagram given, unit velocity time graph. You have to tell the nature of the motion. So if you check, it is rising up uniformly and then coming down uniformly. So you can say from 0 to 4 seconds, it is uniformly accelerated, and from 4 to 6, it is uniformly deaccelerated. Fine. Find the displacement at time t equal to 6 seconds. From velocity time graph, to find the displacement, we find the area. So the area is half into base into height. So half into 6 into height is 2. 2 to get cancelled, you get 6 meter. Does the particle change its direction of motion? No, because everything is positive. So it is not changing its direction. Right in example in 11th question, we saw that the graph was in negative, that is below the x-axis. So we could say yes, there was a change in direction, but in this case answer is no. Compare the distance traveled by a particle from 0 to 4 and 4 to 6. Compare means you need to find the ratio. 0 to 4, you need to find the distance, that is half into base into height, which is half into 2 into 4, you will get 4. And in last 2 seconds, again it is a triangle, half into base into height, half into 2 into 2, so you will get 2. So when you find the ratio, it will be 4:1. It will be 4:1. You need to find the acceleration from 0 to 4 and retardation from 4 to 6. So 0 to 4 for acceleration from velocity time graph, you need to find the slope. So 0, the coordinates are 0, 0, and at point at the tip of the triangle, the coordinates will be 4, 2. When you find the formula, when you use the formula y2 minus y1 upon x2 minus x1, you get 2 minus 0 upon 4 minus 0. I repeat, y coordinates will come first, y2 minus y1. So 2 minus 0 upon 4 minus 0, we'll get the answer as 2 upon 4, that is half. Whereas the other one is retardation. You can see the graph is downwards. So the retardation will be, you have to find y2 minus y1 upon x2 minus x1. It is going from 4, 2 to 6, 0. So when you find this, you get the answer as 2 upon 2, that is 1. You will get 1 meter per second square. So the acceleration is 2 meter per acceleration is 0.5, that is 2 by 4 meter per second square, and the retardation is 1 meter per second square. Clear? Next exercise 2C. For this, you have to use 3 formulae which we have studied. Those 3 formulae are called as kinematical equations. I will just dictate the formula. You can just make a note of it because we will have to use it. First formula is V is equal to U plus AT. Second formula, S is equal to UT plus half AT square. And the third formula is V square is equal to U square plus 2AS. Okay, so you will have to use all the 3 formula here. U means initial velocity, V means final velocity, S means displacement, distance or position, and T means time. A means acceleration. So I will read the first numerical for you. A body starts from rest with uniform velocity 2 meter per second square. Find the distance covered by the body in 2 seconds. So the body is starting from rest. So the initial velocity will be 0. Uniform acceleration of 2 means A is 2. Find the distance covered. You need to find S if the time taken is 2 seconds. So I will use the second formula. Directly I will use the formula, that is S is equal to ut plus half at square. U is 0, so U into T will be 0. Half into at square, so half into 2 into 2 square. So you will get the answer as 4. You have to write the units, that is 4 meters. Fine. Let's do the second sum. It says that a body starts with initial velocity 10 and acceleration 5 meter per second square. Find the distance covered by it in 5 seconds. So the body is starting from rest. The body is starting with initial velocity. So U is 10, acceleration is 5. Find the distance covered. Now the distance is denoted by S in 5 seconds. So time is 5. Again we will be using the same formula to find S. S is equal to ut plus half at square. So when you use it, you get 10 into 5 plus half into at square. So half into 5 into 5 square. I have seen students forgetting to square the time. You have to take the square of the time. So when you use it, it will be 10 5s are 50 plus half into at square. So half into 5 into 5 square. The answer will be 62.5. When you add it, you get 122.5 meter. Next sum is very important. A vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 km per hour. After further 2 seconds, it is 37.2 km per hour. Find the acceleration of the vehicle in meter per second square. Is the acceleration uniform? So there are different scenarios given. First they have said it is 30 km per hour. So that is the initial velocity. After 2 seconds, so time is given, it is 33.6 km per hour. Further 2 seconds. So the next scenario is it is changing to 37.2 km per hour. What you have to do is, first you have to find the acceleration in each case. You know the formula to find acceleration is V minus U upon T. Acceleration is V minus U upon T. But the velocity given is in kilometer per hour. What you have to do is convert every velocity to meter per second. So the formula which we will use is multiply by 5 upon 18. So 30 into 5 by 18 you do it. 33.6 you multiply by 5 by 18. Okay. When you do that, you will get the answer. So while doing it, if you do it, you will get it 30 into 5 by 18. So you will divide by 6. So this will be 6 5s are, and below it will be 6 3s are. So you will get 30 upon 3 30 into 5 by 18 you divide by 6, you will get 30 by 3, or you will get something like that. When you subtract, so 33.6 into 5 by 18 you do it, and then 37.2 into 5 by 18. In each case, when you do it, you should get as, I think the here what they have done is they have multiplied it and then they have divided by 5 by 18. That also you can do. What you can do is 33.6 minus 30, that will be 3.6 upon time 2 is 1.8. Then you multiply by 5 by 18. That also you can do it. No problem in that. No problem in that. You can do in that way also. Similarly, 37.2 minus 33.2. Because now for the second case, 33.6 will become initial velocity. 37.2 will become the final velocity. So when you subtract, again you get 1.8. That is, when you multiply by 5 by 18, you get 0.5 meter per second square. So in both the case, the final velocity will differ. Even the initial velocity is differing, but the time is same. The acceleration is also the same. Okay, so we can say it is moving by uniform velocity. Okay, yes. So I gave you two methods. First is either during the start of the sum you multiply by 5 by 18, or the second case what you can do is you can do it later on. When you multiply 37.2 into 5 by 18, you're getting answer as, I think, something like the 31 by 3 you're getting, and 33.6 into 5 by 18 you are getting 28 by 3, and when you do this you are getting 25 by 3. So 25 by 3, 28 by 3 you are getting, and 31 by 3 something you are getting. So when you subtract it, you get 3 by 3 divided by 2, that is 1 by 2.5. So it is uniform.